We're going to do casework on the number of elements in the range of F. For case 1, we're going to say that the range of F contains one element. So for example, when we apply F to all 3 elements in its domain, they all result in the same value. This is sometimes easier to understand as a diagram. These are the 4 elements in the domain of F, and it matches to one element in its range. We actually have 4 choices for what that range can be: 1, 2, 3, or 4. The range of G must be disjoint from the range of F. The domain of G is also these 4 elements. Being disjoint from this set, for example 1, means that the range of G consists of the other 3 elements, 2, 3, and 4 in this case. So G of 1 can be equal to either 2 or 3 or 4. Same for G of 2 and G of 3 and 4. These 4 functions can be equal to one of these 3 values. That's 81 ways to define G. The total for case 1 is the number of choices for F times the number of choices for G. That's 324, and we'll go on to case 2, where the number of elements in the range of F is 2. So for example, the range of F consists of 2 elements, for example 1 and 2. There are actually 4 choose 2 or 6 different output pairs that we could put there. We need exactly 2 outputs of F over this domain of 4 numbers. For each of these 4 inputs, there are 2 possible outputs. That's 2 to the 4th power for each of these 4 inputs. But we want to subtract 2 because this is the situation where all 4 of our inputs would produce one output or the other. And this is actually case 1. So we'll subtract 2 for each of these. Multiplying this by 6 for the 2 different output pairs gives us 84 choices for F. If 2 of our numbers have been chosen as the output of F to make G disjoint, we choose the other 2. Here there are no restrictions on the number of outputs of G, so the range of G can have either 1 or 2 elements. So in this case, an input of 1, 2, 3, 4 can be assigned to either 3 or 4. That's 2 to the 4th, or 16 ways. We'll multiply these numbers to get the total for case 2. That's 84 times 16. We'll go on to case 3, where the number of elements in the range of F is exactly 3. For example, F can map these 4 numbers 1, 2, 3, 4 to 3 numbers, for example 1, 2, 3. In reality, there are 4 choose 3 or 4 choices for our 3 output values. We need to calculate the number of ways that we can assign these 4 functions to exactly 3 output values. The number of ways we can do this, we can calculate by finding the number of ways that the size of our range can be anything, 1, 2, 3, or 4. We'll subtract the number of ways where we can assign F so that the range consists of only one element, 2 elements, or 3 elements. This first quantity is the way that we can assign 1, 2, 3, 4 in the domain to any combination of 1, 2, 3, 4 in the range with no restrictions. For each of our 4 inputs, that's 4 possible outputs. This quantity is just the number of possible Fs in case 1. In case 1, we had 4 possibilities for assigning our 4 numbers to one number in the range. So we'll subtract 4. This is our case 2 quantity. That was 84. This last term means that we're assigning the 4 inputs of our function f to exactly 4 output numbers. We can do that in 4 factorial ways. F of 1 can be one of 4 values, f of 2 can be one of the remaining 3, and f of 3 can be one of the remaining 2. Altogether, this is 144 possible ways to assign f. This leaves one possible value for the range of G, and this is determined by whatever we don't pick for the range of F. This is the situation where all 4 inputs of G are equal to the given output. There's just one way to pick a G that does this. So our total for case 3 is 144 times 1. Now we can find the total for all 3 cases: 324, 1344, and 144. This is 1812. Since we're finding the probability, we'll find the total number of functions, f and g. Our 4 inputs can result in 4 outputs for f and for g. This is 2 to the 16th power. Since 1812 is our numerator, let's factor out the 2's. So our probability is 453 over 2 to the 14th. The problem asks for the numerator, so our answer is 453. If you'd like me to solve any contest problems, please leave them in the comments.